Now that we've gone over the basic shape of exponentials, let's start transforming it, meaning vertical and horizontal shifts. So when I have my exponential function, which is that cb to the x power, and I add something to the end, that is going to move my graph up k units. When I have my exponential cb to the x power minus a number, that shifts my graph down k units. These k's are predictable. Plus is up, minus is down. We've been saying outside, same. Horizontal shifts are opposite of what we think. So when I have c times b, and now in my exponent position is x plus a number, we think of plus as going to the right. This will go to, the left. The left k units, or sorry, h units. And when I have c times b all to the x minus h, minus we think of to the left, this one's going to the right, inside opposite. So inside opposite, outside same. So example 6, use transformations to graph f of x and then answer the following questions. I put a little asterisk by use transformations because in my math lab, if you hover over your graphing tools, you'll see one that says exponential and one that looks pretty similar to it. And if you hover over, it will say logarithmic tool. So you don't want that one, you want the exponential. But all you need to do to be able to graph these is state the base and then tell what the horizontal and vertical shift are, and it will graph the rest for you. Now for us to graph, we're going to use our calculators and we'll use our table of values to plot some points, but they will graph it for you based off of these two pieces of information. So here first, what is the base of this exponential? And I have a base here of 2. And then what is the horizontal and or vertical shift? So this x minus 1, minus means to the right, and minus 3, minus means down. Okay. So once you put that in, you get the graph. So for us, let's put this into our calculator real quick. So 2 to the x minus 1. Notice it's in the exponent position. You need to arrow over and then minus 3. So here's my graph. So what is my domain? It goes from infinity or negative infinity to positive infinity. Your domain is always going to be all real numbers. Now the range is going to change depending on how this graph is shifted vertically. Because this has been shifted down, this is my starting point here. And this is, everything has been shifted down 3 units, meaning my horizontal asymptote has been shifted down and my range has been shifted down. So now my range goes from -3 to infinity, which you can kind of tell here. And if you look at your table and we go far enough over here, it's eventually going to say 3. Now, if you actually arrow over, it's not 2, 3, but my goodness, that is close, right? So it starts at -3, goes to infinity, because that horizontal asymptote has been now shifted down to y equals -3. That's what it's approaching, but not touching. And then where is the y-intercept? We can do this one of 2 ways. One, I already have my table here, so you might as well use it to your advantage. Here is my y-intercept right here. So we have 0, -2.5. But you can also find this by hand. Your y-intercepts always happen when your x is 0. So what happens when I plug in a 0 to this x right here? I'm going to do this in a different color since we don't technically need this, but we have y equals 2 to the 0 minus 1 minus 3. So this is 2 to the negative 1 minus 3. To change this exponent to a positive, I need this 2 to go down to the denominator. So this is the same as 1/2 minus 3. And 1/2 minus 3 is negative 5 over 2. Or negative 2.5. So you can find this by just plugging in a 0 in for your x. Okay, example 7. What is the base? And if you said the base is 5, you were close, but that is not correct. Just like on example 5, when I had 2 to the negative x, we don't really consider this in standard form when the x is to a negative power, or when your exponent is to a negative power. So I needed to change that to 1/2 now to the positive x. So this can be rewrote as f of x equals 1/5 x plus 2. So my base is not 5, it is 1/5. What does this plus 2 do? Well, that plus 2 is not in the exponent, so it's going to move this up 2 units. And now let's graph it to find this. Now, really, we don't need to graph it to find that domain. The domain of any exponential is all real numbers. But if I put this in, and it doesn't matter what version of this you want to put it in, we can see because the space is between 0 and 1, it is a decreasing function, and it's going from negative infinity to infinity on that domain. That range, when you go from the bottom to the top, well, if this is moving up 2 units, it's taking this asymptote, moving it up 2 units. It's taking this range and moving it, the starting point, up 2 units. This is 2 to infinity, and my horizontal asymptote is at y equals 2. If you go here to this table, you can see that as your x is getting bigger, getting closer and closer to what? To 2. Now again, if you come over here, you can see it's just rounding it to 2, but it is not technically 2. Insanely close, but it's never going to technically reach 2. And then where's the y-intercept at? Since we have that calculator out, it's right here at 0, 3. But just to torture you, we can still do this by hand. So if I do it in this form here, we have 1/5 to the x power plus 2. Anything to the 0 power is 1, and 1 plus 2 gives you 3. Okay, let's talk about one more. Example 8 before we end this video. Use transformations to graph and answer the following questions. What is your base here? Your base is e, and e, if we remember, is just a number that is roughly 2.72. What is the horizontal and or vertical shift? This plus 2 in the exponent, plus in the exponent moves it to the left. So what is the domain range and where is the horizontal asymptote? Well, domain for any exponential is negative infinity to infinity. If we are only moving this graph right here from left to right, it doesn't change your range or your asymptote. So your range is 0 to infinity, and your horizontal asymptote is at y equals 0. You're going to have it graphed, right? Once you put the base and the horizontal and or vertical shift, in my math lab. But for me, I will graph this. We can see it is increasing. And if I go to the table, well, so first you've got negative infinity to infinity for the domain, and then the range, if you go far enough, it's going to go to scientific notation because that is really, really close to 0. And you can see it's on that line right there. So 0 to infinity and y equals 0.